So in continuation to my previous lecture, which was on sequence series arithmetic progression, nth term of arithmetic progression, in this video we will discuss about sum of n terms of an arithmetic progression. Before we discuss about sum of n terms of an arithmetic progression, I would like to discuss about one of the greatest mathematician which we had, German mathematician. Grade 3, when one of his teachers was probably not in a mood to teach, came to the class and wrote numbers 1 to 100, and he told his students to find the sum of first 100 natural numbers, thinking that no student will give the answer and the whole period will go into solving that problem. But Gauss was such a genius, within few minutes he gave the answer 5050. Let's see how he found the answer.
When teacher asked to find the sum of first 100 naturals, 1 plus 2 is equals to 2 plus 1. So order doesn't matter at all in addition. Hence, sum of first 100 natural number is equals to 1 plus 2 plus 3 up to 100, and the same is equals to 100 plus 99 plus 98 up to 1. Let us consider we represented both by Sn. And if we add these two sequences vertically, we will obtain 2 times Sn equals to 101 plus 101 plus 101 100 times. Hence, 2 times Sn equals to 100 times 100. So, Sn is equals to half into 101 into 100, which is equals to 50 into 101. The same problem can be solved like this also. 3, 8, 13, this is an arithmetic progression where first term is 3, common difference is 5, and the last term is 88. Now, sum of n terms is equals to 3 plus 8 plus up to 88, the same. Because addition is commutative, we can always write it as 88 plus 83 up to 1. And let us add these two arithmetic progressions vertically, we will get 2 times Sn equals to, now sum of each vertical term on the right hand side you will observe is 91, which is again amazing. So 2 times Sn will be equal to n times 91, where n are the number of terms in the given sequence. Hence 2 times Sn equals to 91 times n, and n by 2 times 91, which can also be written as n by 2 a plus an, because 91 is the sum of first and the last term, which is also sum of second and second last term, third and third last term, which will always be same for any given arithmetic progression. Hence, sum of n terms of an arithmetic progression is n by 2 times a plus an. Let's see in another example, 85, 81, 75 up to 5. First term is 85, common difference is minus 4, and the last term is 5. Sum of n terms will be written as 85 plus 81 plus 9 plus 5. Since it is commutative, Sn can also be written in the reverse order, that is 5 plus 9 plus up to 85. Adding the terms vertically, I will get 2 times Sn. On the right hand side, sum of all the vertical terms is nothing but 90, and hence twice Sn equals to 90 plus 90 n times, and hence Sn is equals to n by 2 times 90, and 90 is nothing but sum of first and the last term. Again Sn equal to n by 2 a plus an. So one thing is very clear, in any given arithmetic progression, sum of n term is n upon 2 times first term plus the last term. Let's consider that the given arithmetic progression be a plus d, a plus 2d, up to a plus n minus 1 into d, where number of terms equals to n, and sum of n terms will be equal to a plus d plus a plus up to a plus n minus 1 into d. Again, addition is commutative. We can write the same sum in the reverse order, and we'll apply the same method which we have been applying in last few questions. Add all these terms vertically. I will get left hand side will be 2 times Sn, and right hand side the sum of each vertical pair will be equals to 2a plus n minus 1 times d. So right hand side will be 2a plus n minus 1 times d plus up to n terms. Hence twice Sn equals to n times 2a plus n minus 1 into d, and Sn equals to n by 2, 2a plus n minus 1 into d. So this is the standard formula to calculate sum of n terms of an arithmetic progression. So we have the two formulas till now. One is Sn equals to n by 2 times a plus an, and the second one is Sn equals to n by 2 times 2a plus n minus 1 times d.
So we got the formula to find sum of n terms of any arithmetic progression, and the formula is Sn equals to n by 2, 2a plus n minus 1 times d. And the same can be expressed as n by 2 a plus an, where n stands for nth term of an arithmetic progression.
Find the sum of first 15 terms of the sequence 8, 4, 0, minus 4, and so on. Let's try to see whether it's an arithmetic progression or not. Let us try to find the common difference. 4 minus 8 is minus 4, 0 minus 4 is minus 4, minus 4 minus 0 is again minus 4. It means the common difference is same, hence the given sequence is an arithmetic progression. And the solution is, the first term is 8, the common difference is minus 4, which we just calculated. Sn, we know that sum of n terms of arithmetic progression is n by 2, 2a plus n minus 1 times d. Let's substitute the value of n, a and d. N is 15, a is 8, and d is minus 4, and this is what we'll get after substituting the values. Calculating, we'll get minus 300. So sum of 15 terms of this arithmetic progression is minus 300. If question is asked to check whether the sum of n terms of given sequence forms an arithmetic progression or not, let's see. These are the three examples. The first one is Sn equals to 4 plus 32 times n. Second one is Sn equals to n square minus 2n plus 5. And the third one is Sn equals to 4n square minus 6n. In first case, if I put n equal to 1, I will get sum of one term, which is nothing but the first term itself. If I put n equals to 2, I will get sum of 2 terms. If I put n equals to 3, I will get sum of 3 terms. So this is what I will get in first case if I put n equals to 1, 2 and 3. Now S1 is nothing but A1. In order to obtain second term, I will subtract S2 and S1. In order to obtain the third term, I will subtract S3 and S2, and this is what I will get. The first term is equal to S1, second term is equal to S2 minus S1, which is 32. Third term is S3 minus S2, which is 32. Again 32. It means the first sequence does not form an arithmetic progression. Let's see the second one. In second case, if I put n equals to 1, I will get 4, n equals to 2 will give me S2 equals to 5, and n equals to 3 will give me 8. First term is nothing but S1, which is 4, second term is nothing but S2 minus S1, which is 1, and third term is S3 minus S2, which is 3. So this is how I get the first 3 terms. In last case, if I put n equals to 1, 2 and 3, I'll get sum of 1, 2 and 3 terms. And these are minus 2, 4 and 18 respectively. First term is nothing but S1, second term is S2 minus S1, which is 6, third term is S3 minus S2, which is 14. And yes, the common difference is same. In last case, the common difference is 8 in all consecutive terms. Hence, last one forms an arithmetic progression. So amazing. First two are not arithmetic progressions and the third one is. If we recap the formula to find sum of n terms of arithmetic progression, it is n by 2 times 2a plus n minus 1 into d. And if I expand the right hand side, students observe very carefully, we will get a quadratic equation in n. Moreover, there will not be any terms which will be independent of n. If you observe the coefficient of n square, the coefficient of n square will be d by 2. It means the common difference is twice the coefficient of n square. And if we compare with the given examples, the first one is linear, Sn equal to 4 plus 32 times n is linear. It means it cannot form an arithmetic progression. Second is quadratic, but there is a constant term 5. Hence, second cannot form an arithmetic progression. If you observe the third, yes, third satisfies the formula. It is right hand side is quadratic and there is no constant term. Hence, if Sn is given to you, you can immediately tell whether that Sn belongs to arithmetic progression or not.
So friends, it's a very important observation that whenever sum of n terms of any arbitrary sequence is given to us, it will be sum of n terms of an arithmetic progression if number 1 it is quadratic, number 2 there is no constant term. And in the same quadratic expression, if we substitute n equals to 1, we will get the first term of arithmetic progression and twice the coefficient of n square will give us the common difference. So, if Sn is given to us, we can form an arithmetic progression. Let's look into these examples.
In first example, Sn equals to 2n square minus 6n. Yes, RHS is quadratic and independent of a constant term, means it is associated with an arithmetic progression. If we put n equals to 1, we will get minus 6 plus 2, which is minus 4. It means the first term is minus 4 and the coefficient of n square is 2. Twice of 2 is 4, means common difference is 4. It means my arithmetic progression will be minus 4, 0, 4 and so on. Second case, second example, Sn equal to minus n square plus 8n. Again, it satisfies the definition. Right hand side is quadratic and there is no constant term. Hence, it is associated with arithmetic progression. And if I want to form an AP, if I put n equals to 1, I will get 7. Means the first term is 7. Coefficient of n square is minus 1. Double the coefficient of n square is minus 2, which is a common difference. So first term is 7, common difference is minus 2. My arithmetic progression will be 7, 5, 3 and so on.
So friends, in these two videos, I try to explain the concepts of arithmetic progression, sequence, series, finding nth term and sum of n term. I hope it will help you. Wait for my next video.